Hey, welcome back to our breakout lab. This is breakout 11. This is part 2 of breakout 11. In part 1, we implemented our block class, replacing the block structure that we had, and we implemented the basic object with properties and methods for our block. We didn't see anything new show up in our game since we were just replacing that functionality of a block for the walls and for the bricks. But in this lab, we're going to add something new. We're going to add the player paddle. So let's get started. I won't be switching back to Linux this time, but just add new files the same way we did in part 1. So let's look at adding a player paddle. So I'm going to come over here to my project and I'm going to do an add a new item, and we always start with the header file, and this will be paddle.h. All right, and we're going to see, I'm going to come over here to block.h, and we're going to see that in essence, a paddle really is a block, although we're not going to do it through inheritance. We're going to do it through more of like an association or aggregation, where really we're going to create a whole new class called paddle, and it's just going to have a block in it. But what we're going to see is it's going to be very, very tightly coupled to a block. So what we're going to do is we're just going to copy this whole block.h. I'm going to copy and I'm going to come over to paddle.h and get rid of that pragma, and I'm going to paste, and then I'm going to come up here, and this file will be paddle.h, and this is the declaration of a player paddle block class object. All right, and so this needs to be paddle, and we change that. So in our header guard, we change the if not defined and the define. And before we forget, jump all the way down and just make sure your comment down at the bottom is updated for your end if. And then in here, instead of being class block, this is going to be class paddle. Right, and then we are going to change that here for the constructors. But notice our constructors are going to stay the same because we're going to implement a block inside the paddle. And then we're going to need the FGCGL header file. We're also going to need the block header file included. So include block.h. Right? And then when we come down, we're still going to use the same getters and setters. We're going to have to add some additional ones, but this is going to save us a huge amount of time. We're going to use these member methods. We don't need, well, we can leave this. So I'll show you what we're going to do is we're going to see how we would implement these methods as pass-through to the block object that we're going to have. We're going to need the draw. We don't really need the draw with border, but we could draw the paddle with a border if we wanted. So we'll look at that. Maybe we'll implement a colored border at some point for the paddle. But okay, so here's what's going to be different. Instead of having an integer x position and y position and width and height, we're going to have some floating points. So I'm going to get rid of these, and we are going to implement first a block. We're going to just call it the paddle, and then we're going to have some floating point values because we need to keep track of the floating point location, our x and y coordinates multiplied by lag added to the velocities added, multiplied by lag added to the x and y coordinates. So what we're going to have is we're going to have a current x coordinate and a current y coordinate, and then we need a velocity. And I'm sorry, we don't need the color property. because it's inside the paddle. So our paddle, which is of type block, has an X position, a Y position, a width, a height, and a color. We're just adding on to that a current X, current Y, and velocity. So one of the things that needs to be different here is our get X and get Y and set X and set Y now need to be floats. And we're going to see how we're going to implement that, where we update both the current X and current Y as floats and the integer X and Y that's inside the paddle. So we'll see how we're going to do that, but we need to do these as float. And then notice the width and height would stay as integers. They're just inside the paddle. We'll implement these as pass-throughs. And same with these as pass-throughs to the paddle. And then what we need to do is we need to add for velocity, we need to add a getter and setter for it. So we're just going to add a floating point get velocity and a void set velocity. And notice we only have one velocity because our paddle can only move left and right. It can only move horizontally, so we just need a negative velocity to go to the left and a positive velocity to go to the right. But it needs to be a float value. All right, and we're not going to implement getters and setters for the paddle yet, but we will be implementing that later. All right, so that's it for the header file. Let's go ahead and start to set up the C++ file for this. So we come back over to our lab and we do an add, a new item. And this will be a CPP file, and this will be called paddle.cpp. All right, and I'm going to come over to paddle H and copy this block. And in paddle CPP, change the file name and change this to implementation of a player paddle class object. All right, and then of course we need to include paddle.h. Keep wanting to say player paddle. All right. Come back over to our header file for paddle, and we need all of the methods. So just copy all the methods. Come back to paddle CPP and paste. All right. So we need to. I'm gonna grab this here and go ahead and notice I'll only do that in the implementation file. But it gives me a nice break between where my constructors are, my accessors, and my member methods. Right, so right now we're just going to focus on what we brought over from the block class and getting that up to date. So we need to add our namespace here. So remember I did that Alt-Shift down arrow and Alt-Shift down arrow, and then I can paste. Let me copy one of these. And then our width and height are ints, and our color and our new velocity. Remember this, the namespace only goes in front of the method name. And then for all of the setters, and then for these methods, and is empty, and for our draw. Now, if we were doing inheritance, we wouldn't need to do all these methods because we would just inherit them, but that's a little bit more involved than we want to get right now. Okay, so right now, all of these semicolons need to get changed into curly braces. So I'm just going to do a global find and replace. Oh, it's still there. Current document, replace all. Now all this red will go away when I save. All right, so for our paddle, all right, so this would be our default. If I come over to block CPP, I could have used some of this, but I can just copy it now. This is going to be our default constructor. Come back to paddle, and I could paste that here. And then likewise, while I'm here, I can grab this one for the property constructor. Come back to paddle and paste that. All right, so what we're going to do is we just need to set basically for the properties that we have in a paddle. Remember, we normally just come in here and copy these. These are what we need to set. When I come back to paddle CPP file and paste these, remember I've got to get rid of the data types because I don't want to redefine these as new variables. I want to use the actual properties. So to initialize the paddle, which is a block object, I would just make sure that I'm calling the default constructor of a block so that that would become an empty block. For these were float properties, so I just want to use a float literal to initialize them. All right, and that would give me a blank paddle. All right, and then for this, remember, that doesn't look right. Let me back over here. Thought we made that green. Okay, we want the default color of our paddle to be green. When it's empty, it'll be white because we'd be calling the default constructor of the block object. But here we want that to be green. And remember, we must remove these, we must remove any initial default values when we're in the CPP file. We can only do that in the declaration statement. All right, so so back here in paddle.h in the property constructor, we set the default color of the paddle to green. All right, so what do we need to do in here? Well, just as we would normally do, we copy these from our default constructor, bring them down here to the property constructor, but now we need to implement these properties that are coming in into here. So the very first thing is to call a block, and a block means an X, a Y, a width, a height, and a color. So that's what we were setting here. All right. Now, what we're saying is that we're not going to know a velocity at the time we're creating a paddle. We expect when we first create a paddle, and that's the only time a constructor is called, that it's not going to have any velocity. So we're just going to leave that defaulted to 0. And for the current x and y, we're just going to reuse the integer x and y that are passed in. So that'll be in the block inside the paddle and the current x and y. It'll just automatically convert those to floats. All right, so get x coordinate. So this is the floating point one. We want to get the current x. So we're just going to implement those real quick. Return the current x and return the current y. All right, now for get width, we don't have a width. Our width is inside the paddle block object. So we would return our paddle dot get width. So that's what we mean by a pass-through function, is that we're making it look like the paddle has a get with property, but it's really using its internal block variable to call the get with method. So same thing for get height. Turn paddle dot get height. And then same thing here for color. Paddle dot get turn paddle dot. What's wrong with it? Why isn't it working? Return paddle dot oh, I see. I'm inside the parentheses, not the curly braces. I'm inside the parameter list, and our getters don't take any parameters. I needed to be inside the curly braces. Paddle dot get color. We need a parameter list for the function call. Okay, now velocity, this is our velocity property of our paddle, so we would return velocity. Right, so for our setters, now here, when we get a new x coordinate, we would want to update both the current x and our paddle's block x. So here for our set coordinate, we want to implement this as a method and do current x equals value and our paddle.x dot set x coordinate value. And that'll just automatically convert that value to an int. If we wanted, we could spell that out by casting the value to an int. But it's going to do the same thing. So we don't really need to do that. All right, so same thing for our set y. Notice we're going to leave these kind of cut close together here. That's fine. So this will be our current y is going to equal value, and then our paddle dot set y coordinate value. And notice we can't access the paddle's y position property directly because we're not in a block class, we're in a paddle class. So the paddle here is a block, so we must use the accessor methods to get to the block's private properties. All right, so set width, okay, this is just the paddle, so we would do paddle dot set width and pass in the value. And then paddle dot set height value, and then paddle dot set color, pass in the values, our value. And then here, this is the local velocity to the paddle, so velocity equals value. All right, and so you can see where we're kind of making it look like the paddle is a block class, even though it's not really a block class. It just implements a block class. All right, now these would be passed through as well to the paddle, to the block paddle property. So to get the top, which is what this is, we would just return paddle dot top. And so we just need to do that for these. Return paddle dot bottom, and then return paddle dot left, and return paddle dot right. All right, so inheritance, which we'll cover in the object-oriented class if you haven't already taken that, that will go over how to implement inheritance, so you don't need to do all these pass-through. But for now, this works. We're not, our paddle is never going to be empty, but we could implement it, because let's say later we wanted to destroy the paddle and have like multiple paddles, you know, like currently you have 2 more lives. We could use the is empty. So all we have to do is same thing, pass through, return paddle is empty. All right, now, as we get to draw, things are going to be a little bit different, because when we draw the paddle with lag. So we actually need, in our header file, we need to add to the draw method now, we need to add a floating point lag. And this is coming from, in our breakout CPP, when we render. And that's how we would figure this out, is we'd be looking at how do we implement these things. So when we get down to render here, when we draw the objects, we pass in this lag, and we use the lag to modify the velocity, to modify the X and Y position. Because remember, we're drawing total velocity times our frame rate, our current frame rate, so that we're at like 1/60th of the distance per frame. All right, so if we come back to paddle here, we need to implement that floating point lag. All right. And for some of these methods, we do want to have, I'm just going to go watch this. I'm going to go to my block CPP file, and I'm going to scroll down. And for like the is empty, we should have had a header comment. So if I come back to paddle now, over is empty, I can paste that. And then same thing for our block. If I come down here to the render, to the draw methods, you just copy that. And notice for draw, it just calls draw quad here. And so for our paddle, we're just going to be able to call, well, we're going to have to modify the properties to do it. All right, so here, I'm going to copy this from block and come back to paddle. And in here, this is going to be draw the paddle relative to the current X, Y with lag. All right, so to implement this, it's just going to be slightly different in that we need a temporary block that we can modify, because we don't want to update the actual location of the block every time we draw it. We only want to do that when we're updating the paddle at the frame boundaries. But in between frame boundaries, as we're drawing, if the paddle's moved, say 1 pixel in the 4 pixels it was supposed to move, we still want to draw it, move that 1 pixel so it looks smooth. So to do that, we need to only update the X velocity, because, or the X coordinate, because we only have a horizontal velocity in the paddle. So what we're going to do is we're going to create a floating point variable here, and we'll just call it X, and we're going to set it equal to our current X, which is a property of the paddle, plus its velocity times lag. So that will be a new X coordinate, right? And then instead of modifying the paddle block property, we're just going to create a temporary block, and we can just call it, let's just call it current position. And we are going to initialize it with the paddle. Now this looks different. This is not something we've done before. This is called direct initialization. This would be similar to doing equals paddle, right? But this would happen at runtime, and this direct initialization is set up at compile time. And we want this because the compiler is going to put together some code for us that we don't want to have to write ourselves, which is going to be what's called a copy constructor, because our paddle is a block and it's already going to have an x, a width, height, x, y, and color. And we want to create a temporary block, but we want to copy all those current properties from the paddle into this new block structure. And so by doing this direct initialization, the compiler will set up the code for us. It's called a copy constructor. And so we're going to do that, and then we're going to call on current position, we're going to call set x coordinate, and we're going to pass in that x. Now notice it takes an int, but it'll just truncate any fraction from our current, our floating point x. And then we can do our current position dot draw. So we're just doing a pass through to draw the paddle as a block. All right, so to implement the draw with border, we'll go ahead and do that. That's super fast. If we go back to our block, we can copy its comment block. And come back here, and paste that here. And of course, this is the paddle, draw the paddle. All right, and then likewise, we're going to share similar code. So I'm going to come back here to block CPP, and I'm going to copy this code. And then come back to paddle and paste that there. And the only difference is going to be that when we create the background here, we're going to do similar in that we're going to first, this is going to need a lag property. So it's going to need a floating point lag, and that's going to be required. So we're going to put it up front. And when I need to come back to paddle.h and add that property here, the parameter, sorry, and then come back to the implementation, right? And then what we're going to do is we're going to initially, when we create the background, we're going to do it kind of similar to this. We're going to copy, we're going to initialize it with the paddle property. And then we're going to just set the border color. So we're going to set the color by doing background dot set color, and we'll pass in the border color. All right, so we initialize this temporary block by copying the paddle. So what I forgot is we still need this property here. We still need to create this floating point property, and then we're going to need to call the set x coordinate on it. And that's going to be background set x coordinate. Okay, so now for this one, for the foreground, we need to be able to modify each of the properties. So we can do it in the same way and then use the setters and getters to modify them. Or we could do an initialization like this. And maybe that's what we'll do. I'm thinking that's what we'll do. Matter of fact, I think we're going to do it like this. Let's just do an int y, and let's do paddle.get y coordinate. Oh, and it returns a float. So let's just go ahead and do that as a float. Oh, I'm sorry, we didn't even need to call that. We could just do current y. And then let's do float up. Let's do int width equals paddle.get width. And int height equals paddle.get. This will be less confusing in the long run. And then let's do FGCUGL color. And we'll just do color equals paddle.get color. All right, so now we have some temporary variables. And what we can do is, instead of doing the copy constructor and all of this, is we can now kind of, matter of fact, I'm going to come back to block, and I'm just going to recopy this code because this will be easier. I'm going to recopy this code, and back here, I'm going to overwrite all of this. This is going to be simpler in the long run. So what we're going to do is, this will now be these properties. So this will be x and y, width and height, and border color coming from here. All right, but notice the x has been modified, the y has not. All right, and then down here, this will be x plus border size, y plus border size, width minus the 2 times, height minus the 2 times, and then the color of the paddle. And then we'll draw. So here we just create these temporary variables real quick, just because it kind of helps keep things clean. All right. So let's see where we're going to implement the paddle. In our breakout, our main application file, we scroll up here. Right now, we process it, we create our bricks, we process input, we do an update, we pass all of these structures to it, we do a render, we pass these to it, and here at the top of main, we create things. So we're definitely going to want to create our paddle here, but we're going to need to update the paddle, and we're going to need to render, which we already know how to draw the paddle, but we need to think through updating. So let's scroll down to our update method. And when we see in our update, if we look at, say, the ball, we adjust the velocity based off of what direction the user has chosen. So that now needs to become the paddle. And then we adjust the ball's position using its velocity and lag, and this is actually updating the ball's current x and y floating point properties. So this is the permanent update on frame boundaries, because update's only called on frame boundaries. And then the rest of this has to do with the ball, and we'll need to add collision checking between the ball and the paddle, but the collision checking is a method of the ball, not the blocks. All right, so really all we need to do is handle direction and updating, and then of course we've already handled rendering. So let's look at how we're going to implement that in the paddle. So let's come back to our paddle. We'll come to the header file, and what we need to do is, first of all, our paddle's going to need to have direction. And one of the things we're going to do to implement that is we're going to give the paddle its own direction enumerator. So we're going to come up here, and inside the paddle, above the constructors, but inside the public interface, we're going to give it a global, this is where we do global defines. And we're going to define an enum called paddle direction, and then it's just going to have none, left, and right. And we don't care what the values are. We don't care that this is going to be 0, 1, 2. It doesn't matter because we're always going to use the names. Right? Now, anything that includes paddle.h will have access to paddle direction, but we'll see we have to prefix it with the paddle namespace. So then we need to know what the current direction of the paddle is, and we'll be able to calculate that. But let's set up a property, a member method for that. Now, it's going to appear like it's a property, so it'd be like a get method, but so we're not going to use get in front of it because it's not an actual accessor, but we'll just say this will be the paddle direction. I'm just going to copy that so I don't have to type it again. It's going to return a paddle direction, and we'll just call it current direction. Right? And then down here in our draw is like a render. We need a void update, and it's going to be void because we're not going to the paddle doesn't end the game, so we don't need to return any kind of like boolean or anything like that. But to update the paddle needs to know what direction the user wants to move the paddle, and that's going to be a paddle direction, and we'll call that next. And then it needs to know where the left wall and the right wall are for collision checking of its own, because we don't want it to shoot through the wall. So we're just going to pass those in as 2 blocks. We'll pass in the left wall and the right wall. And then it's going to need to know what the current lag in the frame rate is. So we'll pass that as a floating point property. Right, so we have 2 new methods that we need to implement in our implementation file. So we'll first we'll copy the current direction method. Notice they're green because they haven't been implemented. And we'll come over to paddle, and that was, let me see, where did I put it? I put it above is empty, and let's put it below is empty, since it's really part of update. So we're going to come into here and into our implementation file and find is empty. There's it. And then just below it, we're going to implement the new paddle current direction. So we need to put paddle namespace in front of it. Try to always get into the habit of doing that first, right? Okay, and then this needs to be a function. All right, and then in the implementation file, this is going to seem kind of weird, but we need to tell it that this paddle direction data type is actually coming from the paddle namespace. Right. Now, inside the method, we don't have to use the namespace to reference that. But since we're going to have a return type of paddle direction, we should set up a variable here and then return it. All right, and we can initialize it here to none. Right, and it'll recognize none as the enum from the paddle direction namespace. All right, now to calculate the current direction, we first want to know basically, does the paddle have any velocity? Is it moving left or right? And then if it is moving, is the velocity negative? If it is, it's moving to the left. If it's positive, it's moving to the right. But our velocity is a floating point value, and floating point values are very difficult to do like equality checks against. So we're going to use some functions from the math library. So we're going to include math.h, and that's a system library, so we should include that first. So we use the chevrons, math.h. And this will be for velocity checking. All right, and when we come back down here to our paddle direction, what we're going to do is first we want to know, is the current velocity 0? And so in the math library, we have a function for that, for testing if a floating point value is 0 or not. And I'm just going to implement these. We don't really need to spend the time looking them up, but you can go to our reference site and look them up. But we're going to do if, and the function is called f floating point classify, fp classify, and we pass to that function the velocity property of the paddle object, paddle class, and then we can test that for some return constants, and we want to look for 0. All right. And so if it's 0, then we have no direction, right? So we can just set direction equals none, right? And actually, if I'm going to do that, then I don't really need anything up here. Okay, so now if it's not 0, then it's got to either be positive or negative, and so I can do that with another method from the math library called signBit, which is just going to tell me a 1 if it's a negative value, a 0 if it's a positive value. And so once again, we're checking the velocity. And since it will return a 1 or a 0, a 1 would be considered true, so this will tell me if it's negative. And so I can go ahead and implement the negative by saying the direction equals left. So if it was 0, then it's positive, and my direction is to the right. And so I just implement that as an else. All right, so let's give this guy a comment block. Determine current paddle movement direction from its velocity. None equals 0. Left equals negative. Right equals positive. Returns a paddle direction. Direction paddle is moving. All right, doesn't take any parameters. All right, so there's our paddle direction function, and now if we come back here to our paddle H, we need to implement updates. Let's copy that. So this is going to be in the paddle class, and we need the body of the method, and then a quick comment block to say update location of the paddle each frame relative to lag, and perform collision checking with left and right walls. All right. And then so parameters, it takes in next, which is the user keyboard input, left wall, location of left wall, and right wall, location of right wall. Sorry, I get anal, you know that. And then lag is current frame lag. All right, so how are we going to implement the update? So first of all, let's see if the paddle is moving. All right, so let's go ahead and get what the current direction is. So we'll do a paddle direction, and we'll just call it current direction. And we're going to call current direction, which is a method inside this class. And that'll get us either none, left, or right. All right, and then now we know what direction the paddle is moving. We want to know, is the user actually holding down one of the direction keys? Is player holding a direction key? And we'll know that because let's see if the player is not. Player not holding down the direction key. So that would be if our next that was passed in is none. So if next equals none. All right, otherwise, else, all right, else player is holding a direction key down. All right, so that's our two cases. Is the player actually holding like the left or right arrow or A and D keys down? If not, we'll be up here. If so, we'll be down here. All right, so if they're not holding the direction key down, we want to know, is the current direction, is the paddle moving? So if the current direction that we got up here, if that does not equal none, then the paddle is actually moving right now. So in other words, it has a velocity. So if paddle is moving, so if it is moving and the player is not wanting it to move, then we want to actually slow the paddle down. All right, so slow paddle to a stop eventually. And the way we're going to do that is we just need to know at this point, is it moving left or right? So if current direction equals left, then the velocity is negative. All right, and so I actually need to implement one more thing real quick. We need some private constants for the paddle. So I'm going to leave this right here, and I'm going to jump up here to the top, and up here above the constructors, in the global space, we're going to define two constants real quick. We could put these in our breakout header file, but the nice thing about this is these constants only pertain to the paddle, and they're not going to be referenced by anything outside of the paddle, so they're kind of private to the paddle. So we're going to put them here in the global space of the paddle's implementation file. If we were to put them in the header, then anybody that includes the header could reference them, and that if we needed that, we could. But we're going to do a float, and we're going to call this our acceleration speed, and of course I'm abbreviating, and we're going to say that's going to be 6 pixels per second. And then we want to have a max speed, and I should, since these are floats, I should use float literals, so I'll do 6.0, and our max speed is going to be 300 pixels per second. All right, so that's the fastest we're going to let the paddle move. So I'm going to come back down to our update method, and so to slow the paddle down, we are going to simply add acceleration using the opposite sign. All right, so let's think about that. If the paddle is moving to the left, its velocity is negative. And so if we add acceleration as a positive to that, that would start to slow the velocity down. So we want to modify our property velocity, and we can just add to it our acceleration speed. All right. Else the paddle must be moving to the right. All right, so if it's moving to the right, the velocity is positive, so we can subtract our acceleration speed. All right, and you're going to see the effect that this is going to give because our paddle is we're going to speed it up with our arrow keys, and then it's going to gently slow down when we release the keys. All right, so this is paddle is moving. All right. All right, so now if the player is holding a direction key, now we just want to accelerate in whatever direction they're holding. And so we'll see if you're holding in the opposite direction, you will actually decelerate the paddle first before you start to accelerate it in the other direction. All right, so let's see how that's going to work. So now we want to know if the next direction is to the left or the right. So we can implement that as so we want to accelerate. I know I'm spelling this wrong. Accelerate the paddle in user direction. All right, so we just need to know if next equals left, then we need to accelerate by subtracting. So velocity minus equals acceleration speed, and then otherwise you're going to the right, so we just add it. Velocity equals plus equals acceleration. All right, now this is me. This is end. This is update. And this is holding direction key. All right, now here's where we want to make sure you can't accelerate past the max speed. All right, so what we're going to do is keep speed at or below max. So all we need to do is just see, hey, has the velocity reached the max speed? And we're going to do that using the absolute value of our velocity. In other words, we don't want to care whether it's positive or negative. We just want to know, would the positive version of it be greater than our max speed? All right, and if it is, all right, this is max speed check. All right, so then if it is, then we want to do something very similar to this. So I'm going to copy that. All right, but we're going to say, instead of subtracting from velocity, we're just going to set velocity to the negative max speed. Otherwise, we're going to set it to max speed. In other words, we're going to cap you at the max speed. All right, that's going to handle our acceleration. Now, if we look at breakout, we handle acceleration here for the ball like this, and then we adjust the ball's position doing this. So we're going to do the same thing with the paddle. So adjust paddle position. All right, and so what we need to know is what is the current, what should be the new current x. So we're going to do our current x property. We're going to add to it our velocity property times lag. All right, now we want to update the block object paddle, so we can just do paddle property dot set x coordinate and pass in current x, and it'll truncate that floating point current x to an integer. But that way we keep the internal block updated. All right, so that handles that part. We're almost done. Now we just need to handle some kind of collision checking. So if we come back here, we just need to know, has the paddle reached the left or right wall? And we can do that very simply with check for collision with walls. So we can do, first, let's see if the paddle has reached the left wall. So here's where we get to use some of those properties of the block object. So we can do if our paddle dot left, the left side of the paddle, if it's less than the left wall that we passed in dot right. So the right side of the wall. So if the left side of the paddle is less than the right side of the left wall, we've hit the left wall. And if that has happened, then we want to set our velocity to 0. Right? We don't want to be moving anymore. And then we want to set the x coordinate. I'm going to call the set property method instead of setting the x coordinate directly, and I'll show you why. We want to set that to the left wall dot right plus 1. In other words, make our left coordinate, make the left side, which is the x coordinate, make the left side of the paddle the right side of the left wall plus 1 pixel, so it's off the wall. And the reason I'm going to call the local set x coordinate, if we scroll up, is because it will handle updating both the floating point property and the internal paddle property. So that's just a way to reuse the setters internally. All right. We could have done that here, but here I wanted to add to current x. Here I just want to set the value. Okay, so that's for the left wall. So else if our paddle.right, the right side of our paddle, if it's greater than the right wall dot left. So notice we're not having to add widths and all of that, or subtract widths. We're using those internal property methods that calculate where the right and the left are. Right, so all right, now if this has happened, once again we want to set the velocity to 0. All right, but now we do have to do a little bit of calculating. We want to still set the x-coordinate, but we need to set it to right wall dot left, but we need to subtract our get width, which is a pass-through function. I could have done that up with all of these, with this like paddle left. I could have just done left if our left is left of the left wall, or if the right, because we have those methods implemented locally. And so, yeah, so this I didn't want to call paddle, I just want to call set x coordinate. Actually, no, here I did want to call paddle, because we've already set the current x property. All right, that's it. That's going to handle our update. That'll handle our collision checking. All right, so let's implement this real quick and we are done with this section of the lab. We come into our breakout CPP and scroll up to the top here. And the very first thing is let's create the paddle. So we'll just do it right here between the ball and the bricks. Create the player paddle. All right, so to do this, we first need to include the header file for it. So let's include paddle.h. I was wondering why block.h wasn't included, but it's because we included it in breakout.h. All right, so but here in breakout CPP, we're include, this is going to be the player paddle. All right, and so here we're going to create the player paddle right after the ball in main. So this will be a paddle, and we can just call this paddle. And then we want to fix where the paddle's going to be. All right, so let's do, it'll be at, we want to put it in the middle of the screen. And what I'm going to do is to kind of simplify some of this crazy logic that we have going on. It looks like my code isn't updated here for some reason. It seems weird. It doesn't have the updates that I did for the blocks. Oh. Right, sorry about that. I just noticed I must not have saved when I did some of this, but these should have been constructor calls to a block. So somehow that got unsaved. So yours should already be this way. But somehow I didn't save these changes when I did it. Let me just update that real quick. Luckily, there's not very much difference between a constructor and a class. So very quick change. we'll be changing where the ball is. All right, and so actually we're going to create the paddle before the ball. All right, so this is going to be a paddle. All right, and then so the properties for the paddle, we're going to create them as some integer variables here. So we need an x, and that's going to be at the middle of the window, so kind of like this, window width divided by 2. And then I forgot, in our header file, we need to set up the properties for the paddle real quick. So let me see, we're going to set those up as, we're going to have a paddle width and a paddle height. So I'm just going to set those up right here above the ball. We'll do player paddle properties. So we're in breakout H, and we need to have an int paddle width, and we're going to set that to 96 pixels, which is about 1.5 times the width of a block. And then the bricks, and then we're going to do a paddle height, and we'll just set that to 20, which was the height in pixels of the blocks. All right, but I need these properties here when I go to set up the paddle. So now in the paddle, the int will be window width, basically the center of the window minus half of the paddle width. The paddle width divided by 2. And since this is going to be an integer, we don't need to worry about floating point literals here. And so that'll be our x. Our y will be paddle so what we're going to do is we're just going to set it relative to the paddle height, but we want to take into account where the bottom border wall is. So we've declared our walls up here as blocks, so we can actually use the bottom wall. So walls dot bottom, and we can get its top, and let's add 1 to that, and then add paddle height. So the paddle is 20 pixels high, so we're going to space it 20 pixels above the bottom wall's top, the top of the bottom wall, so that there's a nice even gap between the paddle and the bottom of the screen. All right, and then now all we need to do is create the paddle. So our paddle needs and let's do this as, let's do paddle x and paddle y, pad x and pad y, and we'll do pad x, pad y. The width is going to be paddle width, and then the height is paddle height. Oops, come on, work with me. Paddle height. And then the color, we already defaulted the color to green, so we can leave that. All right, but if we wanted to, we can override it here and just do an FGCUGL. That way, if you want to try a different color, I'll just put in green for now. All right, so that will create our paddle. Now we need to pass the paddle to, what is red right now? Something's red. Ball. Oh, this, I'm sorry, this should have still been a structure. We got a little carried away when I was fixing the walls. The ball is still a structure. All right, so we've added the paddle, and now in our update, we need to pass the paddle to it. So our paddle, and we need to update the paddle, so we want it to be passed by reference, and then in render we need to pass the paddle, but we don't need to update it. All right, so let's jump down here to update, and let's add our paddle pass by reference, and let's add that in here. We have our ball and our paddle, player paddle. And this is where the fun stuff is going to happen. And it's not going to take us very much to update it. We're not going to worry yet about collision checking with the ball, and we're going to leave the direction handling of the ball the way it is, although it's going to be kind of goofy, but we'll see that. But we just want to get this implemented real quick so that we can move on to the next portion. So what we want to do is we want to always adjust the paddle first, and just because we're in a way we're giving the player the chance to get the paddle under the ball before we move the ball and check for its location. So what we're going to do is first we're going to see what direction the user wants to move the paddle. So we need a paddle direction, and remember it's a property of the paddle class, that enum, and we'll call it paddle dir. And we're going to initialize that to paddle none. Okay, and then we need to see we only care if they want to move next. Somehow I got caps lock on if. And here we're looking at the next, which is our local directions, direction classes. We're just reusing this kind of structure here, but we just want to know if the next direction that the user wanted to go equals direction left, then we want to set paddle direction. We want to set our paddle direction equal to our paddle left. All right. Else if next equals direction right, so we only care about the left and right directions, and we can set paddle direction equals paddle right. All right, now I didn't do it, but I could add the curly braces. Sometimes when you really only have one statement, there's really not enough there to worry about it. All right, so now all we need to do is call paddle update. So for our paddle parameter that we passed into update, we want to call its update method, and it needs the paddle direction. It needs the left wall, so that's our walls dot left. That's a structure, remember. And then our walls dot right, and then our leg. All right, and that will update our paddle, our paddle's position. So the last thing we need for this lab right now is to render the paddle. So in our render method, we are now passing the paddle. Oops, paddle. And so we want to add that up here. Location of the player's paddle. All right, and then we'll just, it doesn't really matter where we draw it, but we'll draw it before the ball. Draw the player paddle. And we're just going to call paddle.draw. And we need to pass lag to it. All right, let's see if this builds. forgot in the calls. So here's the call to update in main and the call to render in main. And because we added that, we need to pass our new local paddle variable to it. I do that all the time. I update all the function prototypes, but here's our local paddle. We actually need to pass it in the function calls. All right, now redefinition in the paddle, draw with border. So when we go to paddle CPP and go down to draw with border, we just have to get rid of the default values that we have in the header file. We can't have them in the CPP file. Do it all the time. All right, succeeded. One last thing. Let's move the ball above the paddle. Otherwise, it's going to look weird. So what we want to do is we now want to adjust where the ball is. So let's go back to breakout and jump up to where we create the paddle and the ball. All right, so what we're going to do is we're going to make the ball now relative to the paddle. So what I'm going to do is I'm going to do a float for ball x, and I'm going to set that equal to window width divided by 2, and then float ball y, and I'm going to set that relative to the paddle top plus 1 plus, plus the ball size plus 1. All right, so starting at the top, remember the ball's x and y is the center of the ball, and its size is its radius. So we want to move the center of the ball to the top of the paddle, then go up the radius of the ball so that the bottom of the ball would be right on the top, and then go up an additional 1. And so all we have to do here now is change this x coordinate to ball x and this y coordinate to ball y. All right. Build and run. All right, and there we have a player paddle. The ball's sitting right on top of it. Notice our player paddle is about 20 pixels up from the top of the bottom border. And if we start to move the paddle, notice the ball's velocity is also moving. But notice how the paddle slows down. I can accelerate it, but if it hits a wall, it'll stop. And if I accelerate it, it will eventually slow down. And that gives us kind of a nice, and if it's accelerating this way and I start holding the left key, it'll slow down first and then start to accelerate the other way. And it actually looks pretty smooth. That deceleration kind of makes it nice. All right, so that was it for part 2. Come back for part 3. We're going to finish things up real fast by creating a ball object and moving some of the like collision checking and stuff into the ball class.